us now start the next set of logical operations, which are called as the rotation operations. There are total of 4 instructions in this group in the rotation operation. The first is the RLC. RLC is rotate left through carry. How is it done? This is the bit of the accumulator, the bit pattern of the accumulator, the 8 bits of the accumulator: A0, A1, A2, A3, A4, A5, A6 and A7, and this works with carry. So the 8 bits of the accumulator and the 1 bit of carry are involved in this instruction, and this instruction is basically the movement of the data, and how the data moves and how the data is rotated actually is the rotation operation. So where is the data going to be moved? Where the data is going to be rotated? In the accumulator, and the carry. So what is the direction determines what kind of rotation operation this is. First we are going to do RLC, rotate left through carry. Rotate left through carry says that the left, it will be a left movement, a left direction movement, where the contents of the accumulator here and the carry will be moved in left direction, where the contents of A7, the A7 bit of the accumulator, will move onto the carry. The A7 will also move into A0. The data is moving like this. So the content of A7 will move on to carry, and the content of A7 will also move into A0. A7 is moving into A0. The content of A0 will move into A1. The content of A1 will be moved into A2, A2 to A3, A3 to A4 and so on and so forth. For example, let us take A, B, C, D, E, F, G, H, the 8 bits of the accumulator, and let's take it as the carry bit. Okay, so what happens is, when RLC is done, what happens when RLC is executed? What will happen is, W will be overwritten, the content of carry will be overwritten by the A7, the maximum, the MSB of the accumulator. So A will come here, B will move here, C here, D here, E here, F here, G here, H here, and A will also move on to, A was on A7, it will also move on to A0. So this is how this instruction is executed. The value of carry will be overwritten by A7. Okay. Now let's start with RRC, rotate right through carry. This instruction is named so because the movement of the data is happening in the right direction. What happens is, the content of A0, see the data is moving like this, okay, in this direction. So A0 will move into A7 and A0 will also move in carry. A0 will move in carry and A0 will also move into A7. This is the data movement. Okay, this is the right data, right flow of the data. So when the data is moving, A0 will be coming to A7 and A0 will also be written into carry. The content of A7 will go into A6, A6 into A5, A5 into A4, A4 into A3, A1 into A0, and A0 has moved to A7 and carry. If, let us take the same example, W of the carry, and A, B, C, D, E, F, G, H. So we are moving the data in the right direction. Here the data was moving in the left direction. We are moving the data in the right direction. What will happen is, H will come here. So W will be overwritten by H. A will be, in place of A we will get H. A will move here. B, C, D, E, F, G. So after RRC, what do we get? This content. Okay. Now we are moving on to rotate or left. In both these instructions, you've seen that the data is moving inside itself, in the accumulator itself, and next it's also moving on to carry. In this instruction, RAL and RAR, the data will move as a whole. Here the data is moving in 8-bit pattern, and whatever is in A7 is moving into carry. But the data of carry is not involved. Okay. The whatever is the content of carry is not coming into the data which is rotating. Here 8-bit data movement is happening. Here 9-bit data movement will be happening. 9 bits of data will be rotating. How? See, these are the 8 bits of the accumulator and this is the carry. Rotate all left says that all the 9 bits of the data will rotate left. Okay, so how does it happen? When it is moving left, it's moving in this direction. When it is moving in this direction, A7 will be moving to carry. Carry will be moving to A0, A0 to A1, A1 to A2, and so on and so forth. So A7 will be moving to carry, carry will be moving to A0, and A5 into A6, A4 into A5, so on and so forth. Let's take the same example. W, A, B, C, D, E, F, G, H. So what will happen now? The complete data will be moved. So what will happen? A will come here, B, C, D, E, F, G, H, and W will be moved here. Here W was overwritten, okay, with the contents of the accumulator, content bits of the accumulator. Now, in this instruction RAR, the data, the 9 bits, the 8 bits of the accumulator and the 1 bit of the carry will move in the right direction. How they are moving? In the right direction. They are moving in the right direction. So what will happen? The carry bit will come into A7, A7 will go into A6, A6 into A5, A5 into A4, A2 into A1, A1 into A0, and A0 will be moving in this direction and will go into carry. So what happens is carry will be moved to A7, A0 will be moved on to carry, and AI plus 1, A7 will moved to A7 will be moved to A6, AI will be moved into AI minus 1, A7 into A6, A6 into A5, so on and so forth. This instruction can be used in networking, and it can also be used for multiplication or division. Rotation all left. When let's take an example of 4 bits, 8 bit of data, 0, 0, 0, 0, 0, 0, 0, 1, and this is the carry bit. So what happens is, if I rotate left, what will happen is this will come here 1, 0, 0, 0, 0, 0, 0, 0. This 0 has come here, this one has moved here, and so on and so forth. This 0 has come here. So what this data was 0, this was what 1, now this is what 0, this is 2. Next time it will become 4, then 8, then 16, 32, 64, 128, 256. So this is how multiplication can be done. If you are rotating it right, division operation will be performed. 250, if it is 256, then it will be 128, so on and so forth. Thank you so much.